Here we are given a function f of x, and we are asked to prove a couple equations are true. So the first one is f of x plus 2 is equal to this string of numbers here. So to prove that, I'm going to actually plug in x plus 2 into f of x. So rewritten, that would be 3 times x plus 2 squared plus 5 times x plus 2 minus 2. And now I'm going to go ahead and expand that, distribute, and combine like terms. So x plus 2 squared is the same thing as x squared plus 4x plus 4. If you needed to, you could use the box or FOIL to help you get there. And then I'm going to distribute this 5 here to get 5x plus 10. And then the minus 2 is part of that as well. Then I'm going to distribute this 3 into here to get 3x squared plus 12x plus 12 plus 5x plus 10 minus 2. Now I'm just going to combine all my like terms. So here's my only x squared term. Then I have 12x and 5x here to combine, which gives me plus 17x. Then I have 12 plus 10 is 22 minus 2 is 20. And so effectively, I have now proven here by plugging in x plus 2 into f of x that we end up getting 3x squared plus 17x plus 20. Same idea for this one here. We are asked to show that x plus h is equal to this long string of things. And this one become a little bit more challenging because we're plugging in two different variables. So when I do that, the first thing I'm going to do is I'm going to rewrite, f of x here, 3x squared plus 5x, but I'm going to plug in x plus h, so 5 times x plus h minus 2. Now with this one here, I'll actually show the box here to do this one. I got x plus h times x plus h squared, so this becomes 3 times x squared plus 2xh plus h squared. I'll distribute this 5 to get 5x, 5h, and minus 2. Then I will distribute this 3 into here to get 3x squared plus 6xh plus 3h squared plus 5x plus 5h minus 2. I'm going to move this over a little bit. And the last thing I'm going to do is I'm going to, well, maybe not the last thing, but I'm going to see if I can combine any like terms here first. So here's x squared, here's xh, here's h squared, here's 5x, 5h, and then a constant. So it looks like all of these terms are their own individual terms. Like I can't combine any of them. But really remember what I'm trying to do in red here is make it look like this here. And so I have a lot of the things that I need. For instance, I will kind of cover this in pink. I have 3h squared plus 5h minus 2 because I have 3h squared plus 5h and minus 2. So I'm going to just rearrange here some things to make it look like what I was dealing with before. And now I need x times 6h plus 5. So when I look at those two things here, I see that there's an x on the outside. So I'm going to take this term here with the x and this term here with the x, and I'm going to put those next to each other real quick. And so what I get here is 3x squared plus 6xh plus 5x plus 3h squared plus 5h minus 2. And the last thing I'm going to do here to make it look the same is here, I can see that if I were to look at these two terms here, there's a greatest common factor of x. And so what I would get here after factoring that out is I would get 3x squared plus x times 6h plus 5 plus 3h squared plus 5h minus 2. And so effectively we have, using some algebra, figured out how to rearrange things and make it look like what we were trying to prove in the first place up here, that f of x plus h is equal to that long string of numbers.